Hello, dear viewers. In this video, I'm going to solve another AQ exam question. Now, here is the question one. This question is related to the momentum. Okay, so state inward the relationship between the force acting on the body and the momentum of the body. So we have to define the relationship between the force and the momentum. So simple is that as we know that force F is equal to change of momentum, change of momentum divided by time taken, divided by time taken. This is actually second law in terms of momentum. When force acts on a body, so the momentum changes. Okay, so it means the relationship between force and change of momentum or rate of change of momentum is proportional. Mean the relationship is directly proportional. So if you increase the force, so the change of momentum, rate of change of momentum must also increase. What does it mean? It means if you increase the force, so the momentum of the object changes with respect to time. Definitely by applying a force, when you increase the force. So for example, if any object is at rest position, its momentum is zero. Initial momentum is zero. Now you apply a force, some force on this object. Okay, when we apply this force, so it means when this object moves, so it means the when we increase the force, so momentum also with respect to time, momentum also increases. Okay. Now so simple relation is the force acting on a body, acting on a body is directly proportional to rate of change of momentum of the body. Okay. Now for the part B, a container rests on the top balance. So this is a container, this one is a container, and it rests on the top pen balance, and there is a funnel, and we are releasing the sand particles from this funnel, and sand falls through the large distance. So so there is a large distance that has to cover. This sand covers large distance, and it fall on this container, and container is being filled. Okay, now we have to solve for these questions. Show the velocity of the first, in the first part A, we have to define, or we have to find the velocity that is equal to 5.6. So we need to prove that velocity is 5.6 meter per second. First of all, we define the data, or given information. So you can see that the sand falls at the constant rate of this is the rate of fall of sand. So you can see that unit kilogram per second. So this is mass of the sand falling per second, or mass of the sand per unit time, m over t, that is equal to 0.300 kilogram per second. Now the height is given. This height is given where the sand starts and it fell down. So the total height is given, that is equal to 1.6 meter. Height is equal to S is equal to H is equal to 1.6 meter, because this is actually the distance covered by this. So you can see that this is height. Okay, now the value of G, as it is free fall, so acceleration, we know that acceleration is 9.81 meter per second inverse square. Okay, this is all information that we have. Now we have to prove the velocity of the sand is 5.6. So in order to prove this, we use equation of motion. So equation of motion is 2as is equal to v square minus u square. So we put the values for v. So 2 into acceleration is 9.81, into s is, we have value 1.6 meter. This is meter per second inverse square, and v square we have to define, find, and v initial speed must be equal to 0, because when the sand is starts, its initial velocity is 0. So at the end point we need to find the velocity at the end point. So simple, we solve this for the v square. V square is equal to 2 into 9.81 into 1.6. So we take the square root on both sides. When we take the square root on both sides, we get 1.6. So we get v is equal to, that is equal to 5.60. So this is exactly 5.6 meter per second. Okay, So this is part one. We need to find the speed. Okay, now for the part second part, the calculate the magnitude of momentum. So we have to find the magnitude of momentum in each second, mean momentum per second. It means rate of change of momentum. We need to find the rate of change of momentum, or we can say that momentum per second. Momentum per second. Okay, if time is 1 second. So first of all, I explain the equation. So as we know that rate of change of momentum is equal to applied force. As we know that second law in terms of momentum, that already we defined this. That second law in terms of momentum is force applied on object must be equal to rate of change of momentum. So if we know the value of force, so this is equal to rate of change of momentum. As we know that force is also equal to force on the object acting on the object must be equal to mass per second multiplied by the speed. These two equations, we equate these two equations, okay, in order to find the change of momentum. Okay, so force is also equal to del p over del t, and force is also equal to m over t, mass per second falling multiplied by the speed of the fall. Okay, so it means mass per second is also equal to mass per second is equal to m over t into v, m over t into v, because we know these values. Okay, mass, we need to know multiply mass per second with the speed to get the momentum per second. Mass per second is given in the question, that is equal to 0.3 kilogram per second multiplied by the speed. Speed is given in the question, that is equal to, speed is equal to 5.6. We need to find the momentum per second. So we just multiply mass per second with the speed to get the force, or to get the mass per second, mass per unit. So we multiply, we get this value, that is equal to mass per second in, get answer 1.68. 1.68, and when we round off we get 1.7. So answer will be 1.7 is the momentum per second. Okay, now for the third part, the mass of the container is 0.6 50 kilogram. So it is given that mass of the container is 0.650 kilogram. This is mass of a container. Mass of container. Okay, so the reading of balance after 10 seconds after the sand fall will be 3.82. So after 10 seconds the container reading is 3.82 kilogram. You may assume the second sand comes to us without rebouncing it when it lands in the container. Okay, okay, we have to show this, we have to prove that the reading of the balance, so final mass is reading must be equal to 3.82. So I explain. Okay, I explain this one. Okay, first of all, we have to find the balance reading. Total balance reading equal to first is the mass of container. Mass of container has mass, plus we have to add with this mass of container with this mass of sand. Mass of sand fall in 10 second, and we have to add with this equivalent 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 force reading. So I explain one by one. So first of all, mass of container is given in the question, that is equal to mass of the container is 0.650. Mass of container 0.6 kilogram. Mass of falling sand, so we need to find the mass of falling sand in 10 seconds, which is equal to, so in 1 second, as we know that mass per unit time, per unit second, mass per second is 0.3. If in 1 second its rate is 0.3 kilogram per second, how much in 10 seconds? So we have to multiply with 10 total time. Okay, so that this second can be cancelled, so we have the 0.3 to 10, that is 3.0 kilogram. So in 10 second total sand is 3 kilogram that has fallen. Now we have find the we know the value of mass of container, we know the mass of falling sand. Now we, because as we know that when the sand is falling, it applies the force on the container. When it applies downward force on the container, so the mass must be increased. There's additional mass that is known as the equivalent force reading. So equivalent force reading of balance, which is equal to, so this equivalent force reading can be found by using m is equal to, as we know that we apply second law, F is equal to ma, so m is equal to F over a. So we must need to know the force and the acceleration is 9.8, but we must know the force, and we know that force equal to change of momentum, as we know that also we know that force F is equal to momentum per second is exactly the force. Okay, so it means the momentum per second, the previous part we have already calculated the momentum per second, that is momentum per second is 1.7. So this is also the force, because as we know that momentum per second is also equal to the force. So this is the force, that is 1.7, 1.68, that is 1.7. Okay, so if we know the force, so mass is equal to 1.7 Newton divided by acceleration is 9.81. So this mass equivalent mass reading is equal to m equivalent equal to, that gives us the value that is equal to 0.17, 0.17 kilograms. So we add all the weights. So we add all the masses that we have found. First is mass of the container. So total balance reading is the sum of all the values. Mass of container is 0.650 plus mass of the falling sand is 3.3 kilogram, and plus last one, equivalent mass reading that due to the force that acts downward, because as we know that when the force acts on a body, so its mass is going to change, that is additional mass of 0.17 due to falling sand. So we add this and we get 3.82 kilogram. This is the total mass that we need to calculate. So we have proved. Now, so we have to, in part C, we have to draw the figure. Okay, we have to draw the graph between all this scenario when the sand coming down and it's falling down. Okay, from 0 to 30 second we have to draw the graph between. Okay, so at starting at the starting we know that initially only the mass is the container, because no sand is fallen. When the no sand is fallen, so only we have the mass of container, that is 0.65, that is equal to 0.65. so our reading must be 0.65 first 5 second before, because after 5 second the mass is going to start. Okay, start to land. Okay, the mass going to start to land. So it means initially 5 second our mass, our reading of the balance is only the mass of the container. Only balance shows the mass of the container, that is 0.65. Okay, now when the sand falling down, okay, when the sand falling down, so it makes mass, it first sand will strike with this container, it applies the force on this container. Okay, so there is a jump of the reading, there is a slight jump in the reading, that is 0.17, because as we know that force, we have found the force equivalent force reading, that is 0.17. So there is a jump of 0.7, so 0.65 the initial reading plus 0.1417 for due to the force. So we add and we get 0.82. So our now reading start from 0.82, and then the sand falls constant rate at the constant rate of 0.3 kilogram per second. So it means our graph must be the straight line until it reaches at the maximum point, that is equal to 3.82, that is equal to 3.82. So this is going to happen in the 25 seconds. So we have to draw with the only on the 25 second, just above the 25 second of the. Okay, so this is the 3.82, the total reading of all the reading. Okay, now when the mass reaches at 3.82, now after 25 second, the sand stops landing. Now the sand is not moving down as it stops. Okay, when the state sand stops the force equivalent force reading jumps to zero, mean jumps, it vanishes. Okay, So we have to remove the 0.17 with 3.82, 0.17 with this value. So when we remove this 0.17, 3.82, it will give a 3.65, 3.65 reading. Now we move and our reading jumps to 3.68 here, okay, because equivalent, because now sand is stopped, okay. Now no force acts on this due to falling sand, okay. Now our final reading is 3.68, that is after 30 seconds, because now the sand is not falling, so our final reading is after 30 seconds is. So we can remove these dashes. So simple is we can remove, if we remove these dashes, we get the this graph, this like graph, okay. So I draw this graph, look like that one. For example, when goes straight, then it goes up, then it's maximum value, then it go dumps, and then this one look like this one, okay. Okay, thank you.